Okay, good morning, everyone. My name is Ines Henrahan. I'm going to be the moderator of this panel. I'm the executive director of the Washington Tree Fruit Research Commission. And what we are going to examine today is actually something we haven't done so far, and that is the biology of things, the actual plants. We've talked a lot so far about technology and about AI and about robots, about all kinds of things that are non-living. Today, we're actually going to integrate this with the living system. And as my husband, who's a cherry farmer, would say, is biology waits for no man. And it's a really, really crucial part for getting systems, technology integrated into actual orchards, into actual farms. We really need to also look at this other side of the equation that is the biological portion of it. And so I have a really fantastic panel where we can look at this from several different angles and share some of the things we have learned along the way and also some of the trials and tribulations. So hopefully, especially for technology providers, this will be really insightful to help you guys better match the technology to the actual needs of the growers. So with this, I'm going to just have the panel members each introduce themselves and what their specialty is before we dive a little bit deeper into the topic. So let's go ahead, Jack.
Thank you. So my name's Jack Maljars. I'm based out of Prosser, Washington. So I've been involved in the business for probably 30 years now, maybe a little more, and we focus primarily in viticulture. That's our primary focus, even though we do branch, our business does branch out of some of those other crops that we specialize in. So we're always interested in learning, so we've always looked at innovative equipment, some of the leading edge technology that's coming out. Primarily, most of our equipment is either manufactured by us or imported out of Europe. And so we try, our main focus is to try to integrate as much technology into either our own equipment or for our growers in collaboration with some of our vendors that we use out of Europe or South Pacific. And there's a number of different vendors that we collaborate with.
So you said viticulture. For people that might not be familiar with this term, what does this mean?
So as for viticulture, that means vineyards or wine. That's our primary focus. Even though we do have a number of customers that are in the Concord, Juice, Niagaras, but our primary focus is in wine grapes, and we basically focus all over, in geographic areas throughout the U.S. and in Canada.
Okay.
That's where we service.
Thank you. Thanks. All right. So Matt, what's your story?
Hi, folks. Matthew Hoffman. I spent the past 10 years working with Driscoll's. You're probably familiar with the Berry Company, having various technology roles there. And the past 5 years I spent running ag tech programs where we work through a process of scout, select, trial, and deploy ag tech with our independent growers, of which there were about 900 of them globally. Prior to that, I worked in the wine grape industry in Lodi, California. And as of this week, I'm now with Reservoir Farms. We've got a booth down here if you want to get to know about what we do, but it's Ag Tech Accelerator and Venture Capital Fund working in specialty crops.
Awesome, thanks.
Sure.
So we have Matthew and now Matt, I guess.
Great, thanks. Yeah, I'm Matt, I guess, this morning. Only my mother would be upset by that. Yeah, everybody does call me Matt anyways. Good morning. I'm with Washington State University, also in Prosser, at a research and extension center in the middle of the Yakima Valley, which is one of our nation's more productive regions for producing specialty crops. My office is surrounded by commercial farms, wine grapes, as Jack mentioned, blueberries, sweet cherries, apples, hops. And so I run a very applied research and extension program. I also have a teaching appointment. And I specialize in whole tree physiology. And I began 22 years ago at WSU. And a few years after I started, I recognized that there's such innovation in the industry already in the horticulture or tree physiology space, and I recognize the need to collaborate with emerging technologies and my engineering colleagues at that, as you've coined it already, the intersection of biology and technology. And so for 15 plus years, we've been very interested in and collaborating with and developing concepts and systems for just what Inez said at the outset of this panel, the integration of and how one can integrate best current, existing, and even thinking about future technologies into specialty crop production.
Yeah, and I'm going to stay with you, Matt, or Matthew, whichever you prefer. Because I think for the audience it might be interesting to think of, we have here several that are perennial cropping systems, so that means the plant is it's not just like a field crop that you plow over every year, but it's something that stays in the ground for a very long time. So grapes or tree fruit can stay several decades in the ground, so it's stationary. And the grower wouldn't change very fast. But in our area, growers have recognized that they probably need to think about different structures in order to be ready for if and when there's technologies available that can help them in the orchards. And so Matt actually has worked very extensively and intensively on new growing systems that would actually get growers ready for automation. And I think it would be really nice if you could take people on this journey of how you came up with the concept and how it started and where it is today, and what you learned along the way. I think it's a really nice story to also show that it's not just a one iteration, and that from a one concept it goes to a certain, it's kind of like a co-development situation. But in any case, it needs a physiologist. I mean, if you guys don't get anything in this session, it's like if you're a technologist and you have a technology, find somebody with a green thumb. That's why I'm wearing green pants, so you can remember. You need to have somebody with a green thumb right away, and as soon as you have an idea, because if you don't integrate with the plants, you'll regret it. So there you go, Matt.
Okay, sure. Yeah. Well. There was a formative moment in my early career as the Washington State University tree fruit physiologist, where I was invited out to a pruning demonstration. That was probably my first year, and pruning in perennial crops is characterized by a lot of artwork, a lot of interpretation in trees, as anybody who's just pruned their backyard trees can understand. And I was there, put under the spotlight, handed the microphone and said, looking at these large old trees, spaced 20 feet apart, and very complex three-dimensional structures, saying, so where would you start here, Matt? And I remember thinking, oh wow, what have I gotten into? This is a complex structure. This is very complicated in terms of understanding, and where do you start? And I realized right away that those fundamental truths of managing and the artwork that's involved in the interpretation in something as ostensibly simple as pruning in these trees. And the people that do it are truly artists. They've built their craft over decades, and they're very good and very efficient at it. But I wasn't. And I realized one of my motivations was to move from a complex structure that required a lot of interpretation to something that was comprised of buildable units that we could develop rules for, relatively simple rules for. And now, fast forward 22, 23 years later, we have a structure, or at least a vision for a system and a structure, or what we would call an architecture for the tree, the positioning of the limbs in the wood, that is designed explicitly for mechanization, automation. And it has accomplished a couple of things on the way. Maybe when we started that, from my inability to describe pruning rules in a large, complex tree and wanting to incorporate more science into the art, we were looking at simple things in the early days. How do you improve labor efficiency? So what we understood from the beginning was that labor and the expensive cost of manual labor in perennial fruit systems is extraordinary. In fact, in many cases, it's crippling for farmers. And so we began with that premise. How do we improve that? And pruning was one area. We can perhaps talk about other areas later. But it began with the structure of the tree. What are you trying to accomplish? What are the burdens that are placed by this actual structure? So we began on this iterative path of trying to improve canopy structure towards what we now call just generally fruiting walls. Very compact, very narrow. We call them two-dimensional. Of course, they're not, strictly speaking, but relative to the older trees, they're very flat and compact and accessible to vision systems, frankly, to humans and hands. And so we've gone about this long path to improve canopy and labor efficiency and actually generally input efficiency through manipulation of canopy structure.
Yeah, and I would say one of the fascinating stories in this is it really makes it easier to train the trees. In fact, when my husband has integrated some of these systems in his orchard, and when we have tours, often our son, when he was like 10 years old, he could actually explain to everybody how to prune the system. And that's actually really nice because that takes out the guesswork and it makes everything really precise when it's then that simple and not kind of like, okay, should I do this or that, or everybody disagrees on a field day. And I think we can talk about some other benefits when we get a little bit down the discussion. I want to pivot to Jack now. Jack, so you work with a grape harvester, so you basically got the machine, and tell us the story of how that first experience was when you got the machine and you're like, okay, let's get going, let's get picking. How did that go, and how did it evolve from there to make it to the point where you are at today, where now you have a whole fleet employed helping to harvest grapes in Washington?
Yeah, so that's we've been down a pretty interesting journey. So, like I said, I started in was introduced into the business probably 30 years ago now. So if I look at what we were using 30 years ago and what we're using today, there's almost there's almost zero similarity to how the technology has evolved, and it really has. The last 10 years has really increased in innovation. So. Our first experience with so I'm more from the equipment side, the technology on equipment and what it's related to in the vineyard. So we're always looking for, how do we do something with the least amount of cost? And now it's labor. I mean, that's our biggest thing is labor. And so reducing labor, autonomy starting to come into play with that. But really before that, it was more mechanization. That was our focus. So from the grape harvester side, we went from, hand-picking fruit to machine picking to now having machines that actually can destem and sort, and now they're gone to the stage where we're actually doing onboard weighing and creating maps of the vineyard of yields. So there's been a lot of innovation around that. Sometimes some of that stuff it takes a little bit of time to implement. So that's one of our goals was to take that technology, introduce it early, and then implement it. And so, for example, the onboard destemming and sorting, we had a lot of resistance on that when we first introduced that. And it was, there was a little bit of a concept that we were leaving weight in the field by, destemming and leaving some of that, the MOG, we call it MOG, material other than grapes. We leave it in the field rather than taking it to the winery. So from a grower standpoint, we met resistance because they were like, well, we're leaving X amount of weight, which we're getting paid for, in the field. So that has evolved, and the wineries now require, especially on the reds, they're requiring that a lot of that fruit is destemmed and brought in with a machine that is much higher quality than something that we would have used 30 years ago. So, and then that's on the grape harvest side. Then we look at like pruning or mechanical thinning or any kind of weed control, like anything we can mechanize. That is our focus right now, is to mechanize, reduce labor, and do it as efficient as possible with lowering cost to the grower.
Awesome. I'm going to pivot now to Matthew. So in your experience with Triskel's, I'm sure, and you were in charge of R&D, so you probably were exposed to a lot of people that came to you and said, hey, I have this new thing. But on the other hand, you also probably were dealing with like, well, what's the varieties? What's the genetics we should be planting? So to kind of be matching everything perfectly. What were your biggest pain points? Or on the other hand, also biggest success stories in that area? Because you were probably inundated on both sides with
Sure.
like, how did you end up making the decision?
Yeah, well, I'll share something that maybe you guys don't know about berries, but it probably won't be a big surprise. The berry industry is a major market target for a lot of agricultural technology because berries are notorious for very, very high harvest costs, right? 50 to 70% of a grower's annual budget goes to harvest. About 20% is non-harvest labor. So labor is huge, and the real reason for that in harvest labor is because it's a continuously flowering crop. All 4 berries Driscoll's works with: blue, raz, black, and straw. And so in some crops, a raspberry, for example, you can harvest 2 to 3 times per week. Strawberries are about once per week. And so the harvest labor is just constant, right? It's huge. And at the same time, berries are one of the most difficult crops to bring automation to. Not only are the fruit for harvest incredibly fragile, but Driscoll's has the highest quality standards, in the industry, both on, damage, shape, disease coming into our coolers. So the QA specs are pretty high. On the non-harvest side, so non-harvest labor, one of the biggest challenges is infrastructure. Berries these days are largely going to substrate, so farming it in pots with fertigation systems and under tunnel. California strawberries are probably the exception, that there's no trend to get out of the soil, but almost everywhere you go in the Driscoll's global footprint, which is large in Morocco, Peru, Portugal, Mexico, Canada, UK, everything's under tunnel and in substrate. And so you bring the infrastructure, the fact that you have continuous harvest, and there is some standardization dictated by the tunnel infrastructure, but you go from one grower to the next, and the variation is enough that it's a big challenge for a young ag tech company to adapt to it. And so all of those are huge challenges. There are some growers that are doing it very well. I don't think I see him here, but there's a gentleman walking around here today named Liam Maiden. He's with Costa. So Costa is one of Driscoll's largest growers. They don't just do berries, they do other crops. Based in Australia, they also do a lot of production in China and Morocco. And so Costa is an extremely organized farming operation. And one of the reasons they've had such great success with companies like Burrow for harvest assist and autonomy in tractors is because of their organization, because of their standardization. And so that is always something for a grower to first begin with: keeping your house in order, making sure you have enough data coming in to assess whether or not a technology is giving you the return that you want. And then you can start adopting the technology. So frequently there's this shiny object of, I need a robot in the field, but you got to get the house ready for it before you do that. And that's not easy, and it takes patience, and it takes staff dedicated to all that social stuff like change management and identifying processes and how you're going to measure it. But those are really the growers that win with autonomy, the ones that are organized and prepared.
Yeah, that's a good point. I want to maybe bring up another story, and that's in the Apple arena. The Apple industry has also struggled with labor costs, especially for harvest. Over 60% of all the costs sunk in the farm or harvest, and for the past 4 years, 108% of all the profits have been eaten up by labor. Everybody that has done basic math knows that this does not lead to green numbers, that this is a very deep dark red, so that's not a good situation. That's why there's been a lot of focus on trying to get some harvest automation going. And at the same time, growers have been planting a fruiting wall style orchard system, but also a lot of people are planting trellis structures because they can get 20% more yields. So one of the interesting questions right now in the Apple industry is like, which one is the best one for automation? I think that question will be answered in the next couple of years. But what we do know at the moment is if you can grow a canopy that's thinner than 18 inches, that is the best because it's the most reachable for the machine. And also if you have fruit that does not occlude each other, so if it is singled out the best possible, that is always better than not. That is horticulturally quite difficult to do, but those are some of the questions or the adjustments that growers have done that are fiddling with harvest automation for apples.
I'll add, you asked about variety differences, and you talked about it. So something that's unique about Driscoll's and what makes it such a successful competitive company is our plant breeding program, berry breeding. So especially in raspberries and blackberries, where you're constantly releasing new varieties, and you're always figuring out what's the new nutrition program, what's the trellising, what's the planting date, when do you time applications that then lead to harvest timing. A technology company, the cycle of developing something is not too out of sync with a new variety release. And I have seen on multiple occasions tech companies we've been working with really latch on to a particular variety because it accommodates their tech, right? There's a robotic raspberry harvesting company based in the UK that's trying to do something interesting, and they love working with one of our varieties called Reina. Reina already has high harvest efficiency, manual harvest efficiency, because the fruit presents itself in such a way that it's easy for a human to see and grab, so therefore it's easy for the robot to see and grab. But the threat is that they over-index on that one variety, and as soon as Driscoll's has a better variety, something like Reina will be cycled out of the production plan. Maybe it'll take a few years, but raspberries, strawberries, and blackberries are essentially farmed as annuals, and so it doesn't take us very long to 2 to 3 years before a variety that makes up a large percent of the supply to go down to a minority. We've seen other technology companies doing blueberry pollination where there's a physical contact with the stem of the plant itself, really favor certain varieties that the stem is exposed, and other varieties it just doesn't work. So then they look for our growers that are farming FIRA, which is just a nice upright plant. But at the same time, we were trying to phase out FIRA. And so the physical aspects of varieties are huge, and technology companies, it's legit to start with a variety that works with you, but you definitely cannot bank on that variety sticking around very long. If you really want to achieve that full market, you got to find a way to work with all varieties.
Yeah. Jack, in the grape industry, is there any grape that is better than another? Or what would you wish grape? Well, I guess, you have certain, people like Merlot or they like Cab Sauv, so they don't want to necessarily switch. So what's your take on the variety question?
Yeah, that's an interesting question. I've never been asked that. But from our standpoint, from an equipment or a harvest standpoint, we love harvesting Cabernet because it's easy, super easy. We don't like Merlot because it's hard. So but that's from our standpoint. When it comes from from a viticulture standpoint or growing it, there's different varieties that are much trickier to keep healthy. Especially whites. We fight mildew and those kind of diseases or botrytis, whereas the reds they're not susceptible to that like we would within whites. But from an equipment standpoint, we can do it all. So. Very
good. Matt, I'm pretty sure you have an opinion related to tree fruit.
Yeah. I really appreciate you bringing up that integration of all of these aspects. Of course, it really begins foundationally with genetics and breeding programs, and when those breeding programs in the private sphere or also in the public sphere, as we have an apple breeding program and cherry breeding program, breeding and genetics programs at WSU, there's an advantage there, right? And yet it's not integrated with the technology by the sounds of it just yet. But I do want to go back to the foundation of that, of breeding and genetics, of being critical. These are all traits. These are all traits. Understand that the machine, you can modify that in a shop. Probably Jack can make some changes quickly. But if you've planted this perennial crop, you've locked into that longer term investment, and that's a commitment. And it really hurts to have to take that out and put something else in financially. But I think with our longer term prospects, if we think in the 15, 20 plus years time frame, we should have a strong emphasis on the plant traits that really allow for these tools that will become essential probably to the success and sustainability of specialty crop production. And there's a list of those. Matt just mentioned several with the fruiting type, with the structure of the bush or the vine. In tree fruit, we have a couple of key traits as well. Abscission is one. If any sort of mechanized harvest, you've got to separate the fruit from the plant. That's an abscission zone. That's where that happens naturally. It can be induced. And one point, before getting too far down this track, is there is a great variability. Most of these crops we're talking about are rosaceae crops. There's great phenotypic, or the trait. There's a lot of variability in that trait. And that's a really good thing, because when there's variability in the trait, you can identify the genes, genetics involved in the expression of that trait, and you can design a breeding, crossing, hybridization program and a selection program to prioritize those traits. At WSU, our cherry breeding program and my program work very closely together. So far as I know, we're one of the first that have been very explicit in saying we are breeding for the ability to mechanically harvest high-quality, stem-free cherries in the future. And that's integrated into the program. There are hybridizations that are made strategically for that, and incorporating those traits that then integrates into the physiology, the horticulture, the structures, that then ultimately does need to integrate also with machines, tools, and then the whole processing and marketing process. But the integration of all of those is very, very important.
A big lesson Driscoll's learned is that the phenotype that a breeder would select for human harvest efficiency is not that far off from the phenotype they'd select for robotics. So either the human eye or the camera still has to see the fruit, and so less time moving your hands through the canopy to find the fruit, how it pulls off of the plant, whether it's damaged by hands or a harder surface. And so there was this debate at Driscoll's of, do we really need to breed for autonomous harvest? And my argument was, there's a difference between breeding for a trait or selecting for selections as they come through the process, right? You don't necessarily have to breed for all that stuff. You breed for your major traits, which are flavor, shelf life, bricks, etc. And then as you go through that, the breeders will flag selections that could favor automation. But quite frankly, automated harvest in berries is not far along for breeding programs to really make it a priority. I think it'll happen once those machines are available, but it isn't today.
Yeah. So I don't know who runs the microphone in the room. I'll ask one more set of questions, and then we'll start taking some questions before I keep on the monologue. So I want to hopefully this last question also will spark a lot of thoughts with the audience, and that is, of course, the economics of it all. So Jack, from your perspective, how do you run the numbers, or in your discussions with the growers, when do they see that there is enough of a return on their investment that it is actually feasible for them to actually use a machine? And are there differences? Are there different types of growers that see different things that are useful for them? And how, from your perspective, how do you calculate it, if it's worth investing in a type of machine to basically take to the vineyards?
Yeah, there's a couple of thoughts there. So we have a cost analysis that we look at, like a platform for a grower, so you can input your acres and you can input what you're trying to do, whether it's harvesting or mechanical pruning or whatever it might be, and it basically calculates a cost based on cost per acre, and then we input the fuel costs and labor and all those other things. Interestingly enough, we're in a little bit of an interesting time in our economy right now, where we went from how do we become more efficient, how do we reduce labor, but we can't compromise quality. So that was a big thing for a while.
Yeah.
Now we're at a stage where how do we get through this next period? And that's where a lot of our growers are right now. How do we move through this period where the economy is at an all-time low in our industry and get through it at the lowest cost possible. And unfortunately, quality isn't the focus no more. It's like, how do we actually survive? And so we're in an interesting stage right now in our business as we try to help our growers get through this stage of, survival. That's really what it comes down to. So, again, a lot of our technology is value added, and then there's the technology that is actually cost reduction. So, right now, our clients are looking for cost reduction. They're not looking for value added. Like onboard weight scale on a machine. That's not a priority right now to our clients.
Yeah, it's a very difficult situation. I would say in Washington State right now there is only one sector that is halfway profitable, and that's the beef industry. All the other 300 agricultural products are not profitable at the moment. So it's a very dire situation. Anyway, that's just an FYI. So, Dr. Whiting, I know you've done some economic analysis of the UFO system for cherries. So, what did you find out? Does it help? Does it make labor more efficient? Are there any other benefits? Maybe any other unintended consequences even that contribute to the bottom line for a grower?
So Dr. Hanrahan just asked about the UFO system. Is there anybody in here who knows what she was referring to? 3 people. That's pretty good. I would have lost even a bet on that.
Not bad.
The UFO system it's an acronym for the canopy architecture that I was referring to earlier this morning, which is upright fruiting offshoots. It's a structure that's comprised of repeated units that are vertical. Either in a vertical orientation or it can be configured into a V. That's the basis of the structure that has evolved over years of collaboration. And that's awesome that 3 of you knew that. So you're asking about the ROI, or the economic benefits of something like that. And before we have done some studies on that, but I just want to underscore the importance that we've discovered, and as well as others over the years, that when you create these structures, you've improved efficiency, period. Whatever it is. In fact, I even think about it from light harvesting. I mean, a farmer's job is to harvest light, take light energy, convert it into chemical energy. And so we're looking at different structures and densities and ways to do that. These compact structures are very efficient at harvesting light or getting light onto the portions of the plant that the fruit really needs the most. There's a portion of a canopy that a fruit doesn't really need, frankly, but there are very important portions of canopies that are essential to high quality fruit. And so by changing and manipulating the structure, you can influence that. So we find that these structures are very important for input efficiency. And we did some work years ago with a postdoc of mine, Yannis Ampatsidis. He's a great scientist at University of Florida now, where we studied actually harvest efficiency, explicitly looked at harvest efficiency. We took 4 pickers and went to 15 different commercial orchards in the state of Washington at cherry harvest, took the same people, and we picked in different canopy structures, because there's quite a diversity in structure. One of the systems was the UFO, this very compact architecture. And in short, we found that these compact structures were at least twice as fast. The crew working in there was at least twice as fast as they were in an older structure. No mechanization involved yet, but just saying, well, we're dependent upon humans right now, labor. Every cherry and apple is picked by a person. How can we improve their efficiency? And so we could just demonstrate by changing the structure and the architecture, you can have a dramatic impact. What was most interesting actually in that study was we had a mother-daughter team. The mother had been picking cherries for 40 plus years, and the daughter had been picking cherries for about 4 to 5 years. So if I asked you, in the old systems, a large big tree like that one that frightened me on the pruning trial on the first day, versus a very compact, if you can picture it, organized structure, who do you think improved the most going from the big tree to the UFO tree? The mother with 45 years or the daughter with 5 years? Yeah, it was the daughter. This is the emerging demographic. It's not somebody who has been picking cherries for 40 years. It's other people. It's guest workers coming in on visas, frankly. How can we simplify the structure and gain some efficiencies and economies through doing that? And the daughter was extraordinarily fast with that, with picking fruit in these structures. So we haven't done total economic analysis. In fact, I suspect you probably have better data from your home farm. But just the fact that you could, in theory, use half the picking crew if you had a change in structure, or your existing picking crew could pick twice as fast. It's quite extraordinary what we can do just by the plant side of the equation.
Yeah. We usually wait for our UFOs to pick last because people know they're coming and they stay on the crew that way.
This is interesting, actually, right? So if you show those data to a grower, and you have a lot of growers like Inez's family have different structures in the farm. There's some older trees, some newer ones, and different structures. And yet you pretty much would, do you pay the same rate as piece rate for picking? In other words, you said
but the person makes a lot more money, and also because of the increased efficiency, also is a better benefit for the grower. And you can take the ladders out of the system, which reduces accidents. So it's like the win-win-win-win. It just stacks. Everybody wins in this situation. And people know that, and so they're like, they know we got this, and they know, okay, our foreman is very clever, so he talks with them and says, look, we're picking that old piece of the farm first, but if you stick with us in 2 days, life will get easy, and people actually, they like that because they know.
Yeah, and frankly, tree fruit are decades behind small fruit and berries, and certainly further behind vineyards in terms of the structure and the compact nature, right? So we are, some of these things might be a bit obvious to Matthew and Jack, saying, well, we've gone with these compact systems for a long time. I think about automation, mechanization. The demos that were out there yesterday in the orchard demos were largely sprayers, right? To automate an autonomous vehicle with a sprayer, which I would suggest would be relatively straightforward compared to a robotic harvester in an orchard environment, in a complex canopy with different cultivars, different rootstocks, different slopes and terrains. Pruning would even be increasingly complex in terms of the decisions that are made with pruning. If every one of us went out to Inez's farm and we said let's prune, none of us would do the same thing. Probably even on the first branch, we would all be doing different interpretations of how to do it. So that's extraordinarily complex. So it just underscores the importance of developing horticultural structures and concepts and ideas that are thinking about the complexity of those decisions down the line, pruning, harvesting, that are further along in terms of mechanization, like what Jack was describing.
Yeah. So Matthew, would you like to add to the economics question? How did you go about it?
For every ag tech coming through our Driscoll's program, we always did an initial kind of rough cut of grower economics before it entered our program. Whoops. And we would just look at things like, is it a yield increaser or an input reducer? Is that technology eliminating any current expenses? And frequently, it's adding additional expenses. And so you just look at, a net delta for an annual budget for the grower. And one of the big realizations we had was that a lot of technologies, when they have a yield claim, there's probably an additional cost for that grower that year. But the company will say, hey, you're going to pay for this thing probably in the first year or two. But that grower is, if it's a small growing operation, they may not have the budget. And if it's a large operation, it's a ranch manager that has a pretty defined annual operating budget. And so unless they had a bucket of money every year to put towards innovation, they couldn't pull money from another part of their budget to put towards innovation, even if the ROI looked good on paper, because they just couldn't go over their budget for that year. Those technologies that growers were more willing to try in that first year were technologies where they replaced existing expenses for something new, because then they could free up cost, right? And they're willing to do a trial. So that was one economic learning that we had. And the other one was that no matter how much quantification we did of efficacy or labor savings or return on investment, and no matter how much confidence we had in that, we could have gotten data from tens of growers. And you guys you all know this, and you're just going to laugh at it. Every single grower still wanted to try it and get their own experience with it. And so we stopped pouring energy into that analysis. We did enough so that we were confident in it as Driscolls, but then shifted those resources to giving growers an opportunity to try it. So just to reiterate, programmatically, we didn't use the economic analysis to convince growers. We used the economic analysis to convince us so that we would feel good about pushing a grower to try something that we were fairly sure was going to work for them, and the goal was for that grower to make their own decision.
Yeah. Okay, very good. So let's open it up for some questions. We have a microphone going around if you want to just raise your arm if you have a question. We have a lovely assistant back there. Anybody has a question? Yeah, back there.
Thank you. My question's for Matthew Hoffman. How many companies, startups have brought to you harvesting equipment to test? And
A lot.
Have you seen anything that's been viable or
Yeah, well,
potential?
there's automated harvest, and then there's harvest assist. I mean, that's how we divide it at Driscoll's. Examples of automated harvest for strawberries, Harvest Crew is an example. They're working in Florida, for example. You guys have all seen the videos. Little arms go down, grab the berries. And then there's Harvest Assist. Burrow is the kind of the famous example for that, where it eliminates the time and effort for the harvester removing the fruit from the field, right? And so I don't know about a number, but there's no shortage of companies in the past decade that have tried and had too many challenges with the automated harvest. There's still companies trying to do that today, and I always coach them to make sure that they're actually doing something different than their predecessors, because that feedback loop is not always there. And I think the game changer is going to come from something that we aren't really even aware of. Everybody's seen the cool humanoid robots that are being developed. And something I would like to do this year is go to CES in Vegas. Is it Reno, Vegas? And just to get an idea of what type of humanoid arms, we don't need the whole body, just a few of those arms, maybe we'll see in agriculture. And this is something that the reservoir is designed to do, is to attract that technology from another industry and find the right fit to bring it to ag, because at least in the berry industry, the collective opinion is automated harvest isn't working. We're waiting for something game-changing. Until then, we're going to focus on harvest assist. But I think the industry could get really excited if there's something new and optimistic and hopeful. But another arm with 2 or 3 pivots with pallets that grab a fruit just is not going to work.
Yeah. Any other questions? Just raise your arm.
I think I'd add one thing on the economics as well, is that we've seen, back to what we're just talking about, like in the viticulture side of it, what we have seen is the input costs have accelerated rapidly over the last 10 years, especially. But adopting some of this technology early on, that level of cost has been a kind of a flat line. So you have amortization of a cost of whatever it is, technology, that stays somewhat on a flat line. There's maintenance and there's costs there. But if we look back at what it was 10 years ago versus where we're at today, the inflation and the cost of labor and inputs have just skyrocketed compared to what that cost of that technology has done.
Go ahead. There is a question up here. We can just repeat the question. It's okay.
Sure. So I think the same question that we just had on the berries, but for the apples. The automated harvest.
Okay.
Like, what's the state? Is the view the same that it doesn't make sense right now to focus on automated harvesting? We should focus on harvest assist, or is there more optimism?
Okay, so yeah, how do fruit growers, especially in the Pacific Northwest, feel about harvest automation? Matt, do you want to give it a try?
Well, the institution that Dr. Hanrahan represents was founded in 78, 79?
69,
69,
more than 50 years ago.
With the mandate of mechanizing or automation in apple harvest. And so it's been a minute. It's not quite there. There have been actually some very notorious failures in that arena, right? And a significant amount of investment. And the short answer is, of course, there is nothing that's commercially viable today, and probably not tomorrow. There is a concerted effort to pursue that lofty goal of a robotic or unassisted mechanical harvest process for tree fruit. Personally, my opinion is that I think we're trying to run before we walk. One of the challenges is that with what we talked about with structures, with platform-assisted operations, etc., the process of picking an apple, though it is exclusively manual, is very efficient. The people who pick apples professionally are very, very good at it. That's a hard person to beat. And so from a machine point of view, if you're not picking an apple a second or how many bins per hour, it's not going to work. And I think there's room in the interim. And I never felt like we needed to take this massive leap towards fully autonomous robotic harvest of apples or citrus, despite the horticultural innovations that have come along. Instead, looking at mechanical or mechanically assisted processes, I think there's opportunities there to walk before we run. Though it's a cool idea, it's kind of sexy. We've seen the machines, the prototypes out in Washington State. They're fascinating. They look interesting. One came from your world, Matthew, with the advanced farms that was looking like this for berries. They just turned it like that and said, let's look for apples. The economic story hasn't been compelling enough for anybody to make that final leap to commercialization.
Yep, I guess I can add to this, and that is that there is several things that people are looking at. So, for example, the story is still not clear of how efficient the picking efficiency has to be. Is it enough to just pick a first pass 30% of the tops on the tops and on the outside? Or do we need to have 60% efficiency, or do we need to get 100% of the fruit off? That is still actually a question that's actively debated. There are platform companies that have iterated the platform and have made the platform more efficient. There is a company called Automated Ag that now has a vacuum system, so the picker picks directly into a vacuum hose, which is actually really nice, so you don't have to carry the heavy picking bag and don't have to do this moving and bending to put this in the bin. So this is actually, except for the picking motion, everything else is automated. And that is, some growers really like this because they feel they know the platform, it's a local company, they can service, they can train the people, and it's just also a trust factor and something that, you have the local service for it, and it's growing that way. So I think a portion of the industry will go with this, which makes a lot of sense. Then the other question that still needs to be basically answered is the transference of the fruit. Because if you have a robot that makes economic sense and that can indeed pick fast, then you ultimately have more than one apple per second. Usually in this scenario, you would have maybe 4 apples per second that, yeah, you can pick it, but then you have to very fast put it somewhere without bruising. And it's like an egg. You have to basically, and this thing has to be done, but yeah, 4 apples per second. It's kind of like, it's hard. It's a hard problem to solve. So the transference, that's a really hard problem to solve. The other issue is just like what Matthew already mentioned, is the arms. Having some of the bigger companies, what they don't want to do some prototype arm. We've done a lot of research into, can we design cheaper arms, because the arm is really expensive, but the other problem is also, what are the ruggedized arms? Are there any, industrial arms that could be used? And that's actually still, there's still not any of that available. While we have some actually really cheap solutions now, theoretically, for arms, but they're prototypes. They're not picked up by a company yet. And of course, the holy grail is to have, if you do have a robot, ultimately it needs to be multifunctional. It can't just be doing one thing. It has to be multifunctional. And then lastly, and I'm going to actually ask the panel about this too, the other thing is the human factor. So like, for example, with platforms, often when they first came to Washington, people, especially the ranch managers, they didn't want to integrate them. And the reason was because they were already doing a full-time job, and all of a sudden they were supposed to manage this new vehicle, and the people on the machine had to also communicate differently with each other. So the person that was put in charge, it was kind of unfair to them to be put in charge, so this had to work itself out. And so some idea is to basically, especially, for example, for the cyclone picker, is to basically train somebody that's brand new to the farm, and not to have this just put on the ranch manager, but train somebody brand new and train them basically new, so they don't have this knowledge on how things should be. They're basically green, and then have them run the whole fleet. And maybe have some of the checkers help with this kind of stuff. And so those are some really, really important questions. And I think this is maybe also something that I want to ask Jack and everybody else, and that is basically, sometimes technology adoption is not so much the ROI is okay, it makes sense, we got everything sorted out, it looks good on paper, but then the crux of the problem is actually to have people in the field, have the people that actually have to work with the equipment actually like it. How do you get past that hurdle? Because on the one hand, folks are always worried, oh, does this mean I'm going to lose my job? Or on the other hand, or they get put in charge ultimately of another job that they didn't intend of doing, and now they're basically struggling because they have to do so many more things all of a sudden. Yeah, what have you encountered, Jack? How do people handle it, or what do you think how it should be handled?
Yeah, we've seen technology outpace the capacity or the capability of who's actually out in the field, and we've had also pushback of the people that are on the ground doing the work. Pushing back because they feel it's taken their work away from them. And, it always seems to adopt quite easily once they see that it's actually not threatening their job. It's similar to AI. People that are worried about losing their job to AI, I've heard this statement say that we shouldn't be worried about losing your job to AI. You should be worried about losing your job to somebody that utilizes AI. So it's the same thing with mechanization and with a lot of our equipment is if they adapt to it, like for example on the grape harvester or the multifunction, we used to harvest and we'd have a minimum of 3 people involved with that particular machine, plus 2 more tractors. Now we're doing it with 1 person that's driving the machine and 1 person in a tractor. So we've basically reduced it by 3 people to do the same job, and we're much more efficient. We're traveling at higher speeds. And covering more ground. So there is a resistance to new technology, but once it's adapted and they see the benefit and there's no threat to them, it really doesn't become a factor.
Yeah. And do you guys want to add something to it?
Sure. A lot of growers have labor that's permanent on payroll through a labor contractor. They're employees. The growing family or business has invested in the relationships, they're trained, they understand the farm, and that's labor that growers shouldn't and usually aren't willing to replace. And then there's seasonal labor, and by nature of that relationship between the farming operation and that labor contractor or those workers, it is something that is very fluid. They'll move around different parts of the farm, different growing operations, different crops. Sometimes they'll be there 1 year, sometimes they won't. And so it's not just as simple as saying, you know, a technology is going to replace or help labor. Sometimes it's okay and a lot easier if the technology is going to be doing the work of seasonal labor. Sometimes that's very good for the industry because that seasonal labor means that they can go to another crop that maybe has a labor shortage. There are labor shortages. And so it is good for the industry if some of that activities being done by seasonal labor are done through automation because it makes more jobs and we don't have shortages for doing that stuff. And you know, one example of a technology that I think is pretty impressive is a Dutch company called Finefield. They have blueberry mechanical harvesters that are more technologically enabled than some of the other mechanical harvesters. And so that results in easier use and much higher fruit quality, although it's a little bit smaller. And so that still uses one human being to operate it. It's one person with a remote control driving this thing, which isn't too much different than driving a large blueberry harvester. And so it is technologically advanced. It is ag tech. It was a company that was invested in and founded by the blueberry industry. And so they were able to provide the right input and design it. So they were the investor and the customer. And so it's ag tech, but it's not completely transforming how the grower needs to adapt or change. And so I think it's nice to see something that is making a big improvement. Growers are buying these things, but it doesn't feel revolutionary from a process or cost perspective, but it really is technology iteratively getting better for the industry.
We have time for another question, yeah?
Actually, I just wanted to pick up off of a thing that Matthew just said about how a piece of equipment was designed by the blueberry industry and used within the blueberry industry. Do you feel that there is maybe still a disconnect between ag engineering and some of the equipment companies and the agronomy, so that we have engineering and agronomy that aren't fully integrated? And is that slowing the possible development of effective technology in the sector?
Oh, absolutely, and everybody has their own example of it, and you're queuing me up really good to talk about reservoir farms, but that is one big opportunity where if you have a very motivated, eager startup company that's maybe coming from outside of agriculture, how can we make it easy for them to get boots on the ground and start building and developing in situ on the farm with relationships with growers? And so that is where the entire ag tech ecosystem is shifting, and everybody has realized that, and so organizations are being stood up to address that problem.
Okay, one last quick question. Yeah, just ask if we'll repeat it. It's okay, you can just say.
Sure. Dr. Bryan just mentioned about we have a lot of great technology kind of demonstrated at this time, and there's less technology has been like demonstrated in terms of like harvesting, pruning, those kind of things. Like physically, you need interacting with those plants or fruits. So, what are your thoughts about like or suggestions to the tech developers to see how they should start with, like thinking about how to develop better solution for those type of practices?
Well, I think one of the first steps is to acknowledge that it's a longer-term prospect. I think sometimes you see the new players into the field, and I've seen it through the commission and other venues where they'll come in and overpromise and underdeliver. That's the first fatal flaw. I think acknowledging how complex the issues are from the beginning is a foundational step. And then I think it goes to the previous question, which would be full integration of that process from the structures, the trees, the plants, the farmers, the inputs, the people who prune. Actually, if you're to take the pruning example specifically, understand what it is that goes into that. And in fact, that's one of our roadblocks right now. If I went out right today in Washington State with a group that's pruning and said, can you describe to me the rules that you're employing here to make those pruning decisions? The people who are doing it won't really describe that to you because it's interpretation, it's artwork. So we've got to start there and say it's a long-term process, it's very complex. Understand what's being done now and try to simplify systems as much as you can through a collaboration of biology and technology. So it is a longer term prospect. There's a reason that there isn't a robotic pruning demonstration out here, or a robotic apple harvest or citrus harvest demonstration, because they're a long way away from having something that's practicable. But it's certainly worthy of pursuing, absolutely. And we're involved with some of that. I think you are as well.
So bring a plant physiologist along from the beginning. That's always a good thing. And as Matt said, don't overpromise. Keep it real. And I want to close the session and thank the speakers. And I want to also close the session by asking for your help, because you're all working in specialty crops, but the specialty crops are in a lot of hurt right now. But you can help. For example, consider having a fruit bowl at all of your winter meetings. And with this, I'm going to just hand an apple to all of my panel members and to thank them. And yeah, please go and eat some fruit.
Round of applause for the panel. Come on, ladies and gentlemen. Optimizing crop and field design for automation. Did you learn something?